Hello, welcome to module 7. In this module, we're going to discuss about testing first. What is the testing first mindset, and how can we apply such mindset into the real testing activities? Okay, so the first thing is I want to tell you a bit about the increased emphasis on testing. And I think we have seen this kind of graph before when we talk about the cost of testing in the very first few weeks. So usually the traditional software development, we will perform some upfront analysis and we will do some modeling. But the cost of changing the software keep increasing over time. So the time that it's very beginning, the cost of fixing the problem is not very high. But after the time goes by, if you have done any problem and then it has the bug to fix, then the cost is much higher in an exponential rate. So with this, we have the concept of shifting left that we discussed before as well, that we try to do the testing as early as possible. And we want to reveal the problem also as early as possible so that you can fix them and then you lower the cost of the development. The usual assumption is that by doing modeling and doing some analysis, this technique can help us identifying the problems early on in the development. And this kind of saving can be implied by using the cost of change that I just showed before. And we try to show that it justifies the cost of modeling and analysis over the life cycle of the project. But this kind of assumption only is true when the requirement is complete and current and stable. But in the real world, the requirements keep changing. The customer keeps changing their mind, or sometimes they don't actually know what are the actual needs or actual requirements that they have. So sometimes when you develop the software in the middle of the project, the customer might change some of the features, might change some of the functions. And this is come from the human nature that humans are pretty good at approximating, but we are not very good at perfecting. We are not very good at very precise number quantitative measures. So this kind of assumptions that the requirement should be complete and current, and we can apply modeling and analysis, and then we can get the software built as intended, is not very applicable in modern software development. It keeps software engineers frustrated and difficulty for many decades, right? So we have this new methodology that help us, the agile methodology. So the concept of the agile methodology is we chop the work into smaller pieces and we call them a sprint. So in one single sprint, you perform planning, design, develop, test, deploy, and review. So the whole software development lifecycle is done in a pretty short burst of time, like 2 weeks or so. And then you deliver one feature at a time. And then you move to the next sprint. You perform the same cycle again. You deliver another feature, and then you move to the next sprint, and then you keep doing this over and over. So with this technique, although the requirements is changing, but you are committed to only a few requirements at a time, possibly just one requirement at a time. So this minimizes the cost and it reflects better and more reliable compared to the traditional methods that we think that the requirements will always be stable and current and complete. So the difference between agile and waterfall, let's go through them a bit. So the agile methodology deliver the working feature continuously over time, while the traditional waterfall method is you deliver the working software at the end of the life cycle. The agile methodology is good for complex, flexible projects, right? And you have a lot of unknowns, like something that you don't know in the development. The waterfall is not too bad when you have that when you have fixed all the details. Sorry, keeps moving. When you have fixed all the details before the development. Okay. The agile methodology enables changes easily, while the waterfall is more difficult to manage the changes. The agile methodology supports changing requirements, which kind of reflect the real world fast pacing movement of the technology. But if the end product is defined and fixed, then you can use waterfall. Okay. The agile methodology deliver in sprints and you can have small teams, while this one performs sequential tasks. Okay. And you want more stable team. All right. I don't say that agile is better than waterfall or the other way around. It's just choosing the right technique for the right job. Okay. So why do we need to do agile software development? So first, we accept that the assumptions that I mentioned before is not totally valid for many software engineering nowadays. And the software engineers are not very good at doing requirements engineering. We do not, and by following those assumptions, we did not anticipate any changes to occur. And some of the changes that we anticipate actually do not occur as well. So the requirements usually will go out of date. It gets outdated very quickly. So the development is based on something that are possibly outdated in the middle of the project. And usually the requirements are not well regularly updated. All right. So agile methods ignores those assumptions and it expects that the software development will start from small and it keeps increasing, evolving, incremental over time. So we kind of embrace this evolution of software development. We do not expect a fixed set of requirements. We expect them to change over time, and then we adapt accordingly. So the traditional one, we define some of the anticipated change. However, there are some change that are anticipated but it doesn't actually occur, while there are some additional unanticipated change. So in the real evolving software, you would have both anticipated change and also unanticipated change, which may affect the design of the system, the implementation of the system. So we're gonna shift our understanding from the traditional understanding of software correctness, okay, which can rely on some kind of mathematics computation. Like you know that the if you know that the software has the following requirements, the software will be correct if it fulfills all the requirements. In the mathematical ways, if you can model some of the properties and then you get this kind of graph, you know exactly that if it's x is 1, then y is also 1. Okay, so this is linear, right? X is 5, y is also 5, and x is 10, y is also 10. So this is the correctness based on mathematics. But the correctness based on the agile methodology is existential correctness, which means if you know that giving this and this returns true, giving this and this to the software, it returns true, giving this and this, it returns false, then you check whether the software performs such tasks correctly based on the test cases that you have. So these are the test cases. So we kind of make the correctness more flexible, right? So in the traditional method, we try to define all the correct behaviors first at the beginning. So we need to think about what is the correctness. And actually in engineering process, when you build something really, really large, does this correctness mean anything at the end? Can you actually measure it? Because people are very bad at defining correctness and also measuring it. This kind of traditional correctness might not be very useful at the end. So in agile method, we kind of redefine the correctness to be relative according to a specific set of tests. Okay. So if the software behaves correctly on test, then it is correct. So we just need to demonstrate some behaviors that shows that it passed the test. We don't need to define all the behaviors. which might disappoint some of the mathematicians, but we are engineers, right? So we are working on building the real stuff. So this is kind of acceptable in practice. So in software development, we have this concept called TDD, or test driven development. So in TDD, you start with a test. So you start here, you make, sorry, not here. Let me erase it. You start here, and then you write a fail test. Okay, so you move here. You write a fail test first. You start by writing the test, even before writing the code. So that test surely will fail because there is no code to execute the test. So the test is expected to fail at first, and then you start writing code to make the test pass. As long as the test hasn't passed, then the code is not correct. So whenever the code passes the test, this is where that implementation is correct. Then you move to the next phase. It's called a refactor phase. You check whether this code can be improved in terms of its structure and organization. You make the code clean, and then you come back to the first step. And you keep doing this by using the sprint that we discussed. So we keep writing tests for one of the additional features that we want, and then you implement it. You make the test pass, you refactor it, and then you write the next test again. So with this kind of concept, we use tests to verify the correctness. So we run all the tests automatically, and then we report the results to the developer. This is called test harness. So we have some result from automated tests, and the developer is informed what are the progress or what are the status that they are in. This emphasizes the concept that the test must be automated, which we're going to discuss about test automation soon. And every test must include the test oracle or the expected output so that we can evaluate whether the test execute correctly or not. And this test will finally replace the requirements. The test becomes your new requirements. Okay. You still might need to have some requirements, but in the end, when you do the development, the test will finally becomes the actual requirements that you rely on. With this kind of method, we must ensure that the test is high quality and it must run quickly so that the developer can verify the implementation very quickly. And then we run the test every single time that we change the software. Okay. This is possible nowadays because we have this concept called continuous integration, or CI. So in CI, you start by writing, doing some planning. You write the code. You build the code, which means you compile it or integrate many parts, many pieces of code together. And then the key thing is here. You do the test. And once the test pass, you deploy the software, and then you release it. This is also already include the CD part, which is continuous delivery. But for CI and CD, you actually run the test and then you just come back here. Okay, so this is the CI part. This is the CD part. If you go to CD, then you also deploy and then you move on to the next step. Okay, but even the CI part, you do the planning, you code, you build, and then you test, right? And then you keep doing this automatically over time. The developer doesn't need to do the build and the test. This is automatically done for them, but they have to write code first, right? So the coding part include tests and the actual code. Okay, this shows the same thing. So you start by having the version control system, you do some build, and then you do some tests. And if it passes the automated test, then you go to deploy, and then you go back again to get the new source code. So with the concept of continuous integration, it works well with the agile method, right? And we have the software continuous integration server to rebuild the system to return and re-verify the system whenever any update is occurred. So whenever the new code is committed into the repo, this CI process get kickstarted and it keeps running. So with this kind of automated technique, the mistakes are caught early on in the very early phase in the development. And since it runs and it notifies the developer, so all the developers in the team also aware of the changes. And the review and this re-verify or rerunning of the test, running tests must happen as soon as possible. So this kind of CI system and your test must be quick. Sorry. So in the end, the CI server doesn't just run the test, but it also decide whether the modified system is still correct. If the CI system found that the test failed, it wouldn't move to the next step. So the developer needs to fix the code until the test passes, and then the CI process will continue to the next phase. All right. So this is like a gatekeeper before moving on. So in the traditional testing way, the tester rely on requirements. So you go through the requirements, and then you check whether each requirement is fulfilled or not. If all the requirements are fulfilled, then the system conforms to such requirements. But in the modern software development, we might not have these kind of traditional requirements document anymore. If you use agile methodology, the developer team will rely on a user story. So a user story is a few sentences that capture what a user do with the software. For example, I withdraw money from checking account. The system should support the technician. The support technician sees the customer history on demand, or the agent sees a list of today's interview applicant. So with this kind of stories based on the user's perspective, it turns into the actual function in the software. So the user story is written in the language of the end users. It is usually pretty small in scale, and it has pretty one single functionality that is needed in the software. However, this user story has some issues because it doesn't go with the code itself. So sometimes it's not archived with the code. It doesn't get into the repository along with your source code. So what should we do? You have the user story. You turn that into tests. So reading the user story and then you write tests. This follow the TDD method. By starting writing tests, your first set of tests would be failing. And then you start the process of TDD. You make the code until the test pass, and then you perform the refactoring. And then you might need to do the TDD again to make sure that everything is okay. And then you refactoring again. You keep doing this until all the tests are passed. And then you move to the next user story, and then you do TDD again. So this kind of thing links TDD with the agile method and links it to the user stories. With this kind of technique, your tests will be actually archived, because test is also a part of code that is in your repository. So you keep the tests in the repo, you commit them, the tests are archived, it's always there with the software. So with this, we kind of have evolving requirements in the test format for you to look at the end. I mean, over the time, right? So the other things that we might have an issue with is that how can we add the test to existing system? Because most of the software today that we have are legacy system. And this legacy system might not have any tests. The document might be already outdated. The requirement should be way outdated. And the design, not sure that anybody will have this kind of design. So the company got stuck because they are not very confident in changing their software because they fear that the software might have failures. So if a company wants to turn themselves into test-driven development, how can they work with such legacy software without a test? If they generate the whole entire test set, that would be very difficult and it's too expensive to do. There might be like hundreds or thousands of methods to test. But if they give up at the middle, then the project is still having a problem, right? So the suggestion is that we should do incremental TDD. The TDD is adopted in the middle of the project or in the maintenance of one system, but only when a change is made, then you add the TDD test just for that change. And then you do refactor. So as the project proceeds, the collection of the TDD tests will also continue to grow following your updates. So you keep doing this. Eventually, you will have a strong TDD test set. Whatever the software part that you haven't touched, you leave it there. But the part that you keep changing, then you keep adding the test. So with this kind of method, you keep having more and more tests over time. And then in the end, it should cover a large amount of your code base already. There are some of the testing shortfall that people might not be totally believe. The first thing is that do TDD tests test the software well? Okay, we need to know whether the test achieve good coverage on the code, which we will talk about in the coverage criteria, okay, in the next module. How do we know that it covers the good amount of your software? And how do we make sure that do the test find most of the faults? Okay, we need to do some kind of systematic testing technique to do that. And if the software passes, should the management feel confident that the software is reliable? The answer is no, right? We still cannot totally say that the software is fully reliable. One of the issues is that the agile tests, they might focus mainly on the happy parts, which mean the normal use case that the system should behave or the normal input that the user might put in. And this might miss things like confused user part or some creative out of the box that you haven't think before. You might not expect the system to be used this way, but some of the actual customers, they might think out of the box and try something that you haven't thought about. Or there are some malicious user part that some of the people who are not well intended might try to hack into your software. And this kind of agile methodology also doesn't help give much of the guidance on how to solve such issues. So what should we do, right? What should the testers do in this kind of situation? We must define good tests, right? So to decide a good test, first, we can use human-based approach. Depending on the intuition of the testers, you read the user story and you try to think about the non-happy part as well. But there's still an issue that you don't know when you're gonna finish. And some people are very good at this, but some people are also very bad at this. This is intuition and it's difficult to teach. So the second one is that using some modeling technique and some criteria. So we model the input domain. This is what we already discussed, ISP technique. Or you model the software behavior with other representations like graph, logic, or grammars, which we're going to talk about in the next few modules. This kind of technique will help us to be systematic, okay? And when we apply some coverage criteria, we will know that we have some sense of completion. And this kind of techniques is systematic, so it's easier to teach and learn because it's engineering. And it might require some of the discrete math knowledge. Okay, you will see in the next few modules when we discuss these kind of techniques. All right. So to summarize, the thing that I discussed today is about putting tests first. And we can see that more companies are putting tests first because it saves costs over time. And also with the problem of the requirements that are changing over time, this kind of putting tests first will dramatically decrease the cost and increase the quality of the software. By putting tests first, we have a different view of correctness. Okay, we define tests based on the user story or the requirements, and we say that if the software pass the test, they are correct. This kind of idea or mindset embrace the evolutionary design of the normal software in current time. And TDD is not test automation. It is a mindset. It is a technique that you can apply. Also, even though you're not doing test automation, you can still adopt TDD. But by adopting test automation, it makes this TDD more efficient, more streamlined, and faster. And by just doing agile tests, it is not enough. So we need to employ some of the modeling techniques and some systematic test case design to help us. We're going to discuss these many elements in the next few modules. So please stay tuned. See you in the next module.